Hello everyone, this is Astha Pandey. I am explaining about the finite state machine. First we learn about the machine. Machine is a device that receives a set of input signal and produce a corresponding set of output signal. When the number of states are finite in a system, then the signal is called the finite state machine. A finite state machine M consists of a finite set of I of input symbols, a finite set S of internal states, third a finite set of O of output symbols, fourth an initial state S naught in S where S naught belongs to S. Fifth, a transition function f, which is defined at s cross I mapped to the s. Sixth, an output function in g, which is defined at s cross I mapped to o. The machine with six tuples m is equals to I, s, o, f, g, s naught. Next, we represent the finite state machine. And there are two ways of representing a finite state machine. First is transition state table. That is the transition state table. It is a conventional tabular representation of the values of the next functions f and output functioning g for all pairs of state and inputs. The first column in the table lists the present stages. The second column are the elements of the input I given first under f and then assigned under g. Finally, the value of the transition function f are shown in the first two columns under f, and the values of the output function g are displayed in the last two columns of the table. That is defined in the figure. This is the transition table, and the diagram second is the state diagram, also known as the transition diagram. The transition diagram is a finite directed graph in which each vertex represents a state that is in S. All the states are represented by small circles. The initial state be shown by a circle with an arrow to it. The directed edges of graph represent the transition of state, and they are indicated by input 1, output A by X. Next, we define the equivalence of finite state machine. The two states S1 and Sj of a state machine are equivalent if and only if they produce the sum output for any input sequence. For example, if M is equals to I, S, O, S naught, Fg be a finite state machine, and if two states S1 and S2 belongs to both capital S, then these two states are said to be equivalent when S1 is equals to x2 said to be equivalent when both belongs to the capital S. If and only if gs1 comma x is equivalent to gs2 comma x, where x belongs to capital I, where x is the from the set of words on the input alphabets. What is finite state automation? A finite state automation can be represented by a 5 tuple, that is q, sigma, del, q naught, f, when q is a finite non-empty set of states. Sigma is a finite non-empty set of input symbols called input alphabet. Del is a function in which maps q cross sigma into q and is called the transition function. The transition function is that q cross sigma mapped into q. F is the subset of q is a set of finite state. Q naught is the initial value set. Here are some common notations used, that is alphabet. This alphabet is a set contain elements used to form string. What is a string? A string is a finite sequence of the form a1, a2, a3 up to an. It is denoted by a1, a2, a3 up to an bit. Bit is the 0 or 1. Bit string, sequence of 0 or more bits. Empty string, string denoted by lambda, has no terms. Input words, a finite string of symbols where a1, a2 up to an are input symbols. Empty strings, string denoted by lambda has no term. Input word, a finite string of symbols where a1, a2 up to an are input symbols. Length of string, number of bits in the string 1, 0, 1, 0, 0, 1. How many bits is there involved in it is the length of a string. Transition, alternation or change over. Run is defined as jump over from one state to another state. Language recognized set of input strings that take the start state to a final state of automation. Finite state is defined as the number of possible positions are finite. Then we further we define the finite automation. This Thank you.